Hello everyone, this is Hariharnath. In this video, we are going to talk about an interesting project that is IoT based smart water monitoring system using ESP32 and Arduino IoT Cloud. First of all, let's try to understand what is the need of the water flow meter. The water flow meter will ensure the accurate measurement of water movement and also track the water consumption in our smart cities and smart home projects. Now that we understood the necessity of IoT based smart water meter system, then let's move on to the project. As we all know that to create a project, we need multiple components to be procured. If you're wondering from where we get all the components at once, then don't worry, I have you covered. Let me introduce you to the today's sponsor, that is DigiKey. DigiKey is a global leader in cutting-edge commerce distribution of electronic components and automation products worldwide. They provide more than 15.3 million components from over 2,900 manufacturers with products and stock available for immediate shipment. Also, with their fast shipping and excellent customer support, you can always trust that your products will arrive on time and in top condition. So do remember to check out DigiKey for your next project. So this is the DigiKey website, and you can search by the keyword or part number in this place. And this is the major part that we are using, that is ESP32 S3, which is a low power MCU based system on a chip, that is SoC, with integrated 2.4 GHz Wi-Fi and Bluetooth low energy. So this is another component that we are using, that is MAX 1898EU B42 plus T, which is a linear charger with an external PNP or PMOS transistor that forms a complete charger for one cell lithium ion batteries. This is another components, that is ADP1706, which is a CMOS low dropout linear voltage regulator. One more important component for this project is flow sensor with the part number mentioned on the screen. It is half-inch water flow sensor which consists of plastic valve body, a water rotor and a Hall effect sensor. When water flows through the rotor rolls and its speed changes with different rate of flow. The Hall effect sensor outputs the corresponding pulse signal. Let's now look into the schematic diagram of our project. So here you can see ESP32 S3 room 1, which is the MCU that we are using, and here the important GPIO that we need to remember is 47, and another thing is the flow sensor, that is water flow sensor and TDS sensor that we have, and here also you can see IO47. So to IO47 we are connecting so that we can use in that whenever we are using in the code, we can see that 47 pin number of GPIO will be used. And for power on reset, we can see this circuit diagram as well as battery charging, as we said MAX chip that we are using, and power and filtering we are using that ADP1706 that we have already discussed. Let us now look into the hardware. So this is the flow sensor, and then we have this 3D printed case and the cap for ESP32 S3. The case is mounted on top of the flow sensor and it has been screwed like this. The flow sensor connections are wired to the ESP32 S3 with GPIO47 pin, power and ground pin. We have connected the rechargeable battery for powering the board. We have USB Type-C for programming the board as well as charging the battery. Here we can see the switch to power it on. Now let's place the board inside and close the cap. Now I have already created whatever are necessary in Arduino IoT Cloud, and let me show the demo here. So first we need to create a device. So inside the device I need to create ESP32 S3 dev module, and then we have to connect the device. So after this, I need to create a thing. So I have created this water flow meter. So here the first thing that you need to create is cloud variables. Inside the cloud variables, you can see that I have created the flow rate cloud as a float, and then last activity cloud, that is string, reset button as a boolean, total liters cloud as float. And we can see already the associated device that we have already created a device, right? So that is to be associated, and then the network that we are going to connect, and remaining things can be as it is. And next thing that we can see is sketch. So sketch is nothing but the code that we are going to write. So the code is very simple. Here you can see the basic libraries, that is Wi-Fi and thing properties is already included. And as I mentioned in the schematic, that we are connecting the flow sensor with 47 GPIO pin of ESP32S3. So that's why we have mentioned here, and these are the important variables that we are going to use. And inside the setup, we can see that we are initializing few things, and the major important thing is the pin mode, that is the sensor that we have put as an input pull-up. And finally, one more important thing is attach the interrupt. So we are attaching the interrupt to the flow sensor pin, and here you can see the sensor and the pulse counter. So the pulse counter is one method, so that is going to count the pulse. So whenever the water flows through the flow sensor, pulse will be increased. And in the loop, we can see we are using the standard code to get the time as well as the flow rate using the time that we calculate. And finally, we are printing those values and also assigning these flow rate to the cloud variables that we have created. And this is the function to reset the milliliters to 0. Another important thing that we need to look is the things property. So inside the things property, you can see the SSID, password and device key are needed, and that will be provided using secret. So secret tab is there, in which I can provide the SSID name and the password, etc. So after this, I have to connect the water flow meter. So now I can connect the water flow meter. So once you have connected with ESP32S3 module, you need to upload the code by clicking on this. I have already done that, so I'll skip this step. Next thing that we need to do is go to the dashboard. So in this dashboard, you can see the water flow meter. Click on this, and here you can use various widgets to create a dashboard like view. And I can click on this edit and show you this is the value widget, and I can see the edit options where I have linked the variables of flow rate here, and you can see whether the value, decimal value and rounding is done in this way. And the same way for total liters, I can show you that total liters cloud link variable is done, and this is the reset button. So here the function that we have written, and for that a button boolean value is set. So this is how you can create a dashboard, and the same dashboard will be visible on your mobile application. So in your Play Store, you can find out that there is an app called Arduino IoT Remote. You should download that and then view the same dashboard available. Now that we have programmed the board, we can proceed with the demo. One end of the flow meter is connected to the water source and another end to the water sink. We have installed Arduino IoT Remote app on my mobile, and we can see the dashboard with the widget on the mobile screen. Now I will turn on the tap and see the flow getting updated. That's all for the video. Thank you for watching, and this is Hariharnath signing off.
DigiKey,